Hello, in this video, we're going to be talking about quadrilaterals, particularly this branch of the quadrilateral tree of trapezoids as well as kites. Quadrilaterals are this really cool polygon with four sides that has special names that some of which are probably pretty familiar to you um, based on what's going on inside of that shape. And we're going to be exploring these in other videos, but today's video is just about trapezoids and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So in this diagram right here, we've got a set of parallel lines right up on the top and the bottom. And they don't have to be on the top and the bottom. They could be going on the side, but the idea is that you've got a pair of parallel sides. Isosceles trapezoids also have that pair of parallel sides, but they also get an extra bonus thing where these two non-parallel sides are the same. Finally, we've got a right trapezoid where we got that parallel sides, but then one of the sides also makes a right angle, making it a right trapezoid. Now, the thing that we're really interested in is this guy, the isosceles trapezoid, because it gets another cool property based on this theorem. The base angles of an isosceles trapezoid are congruent. So these two angles are going to be congruent, as well as these two angles are going to be congruent, which lets us figure out a lot of stuff inside of that trapezoid. So if this is 117 degrees, then angle 2 also has to be 117 degrees because these two have to be congruent. We also know that these two have got to be congruent, and we can find them pretty quickly. These two angles, this 117 and 117 and 1 are, so 1 plus 117 are, they are same side interior angles, which we've learned about in the past. These two are between these two parallel sides. We've got that transversal, making these two supplementary. So the measure of angle 1 has got to be 180 degrees minus that 117. So the measure of angle 1 is 63 degrees. And since these two are congruent, we can also say that the measure of angle 3 is 63. 63 degrees. All right, so in this one, we can do that same sort of thing. These two angles are base angles, and they are across from each other, so they've got to be congruent. They're base angles on this isosceles trapezoid. So we know that the measure of angle 3 has got to be congruent to that 68. So the measure of angle 3 is also 68. Using the same logic we did over here, we can say that 2 and 68 are same side interior angles. They're in between this parallel line and this parallel line, and we've got that transversal, making them supplementary. So the measure of angle 2 has got to be 180 degrees minus 68 degrees. So the measure of angle 2 is 112 degrees. Now, since these two are also base angles in this isosceles trapezoid, they also have to be congruent according to this theorem up here. So we can say that the measure of angle 1 is also 112 degrees. And that's all done. Now, a kite is a quadrilateral that has two pairs of congruent adjacent sides. So this side is congruent, and we want one of the sides that's right next to it to also be congruent. And that happens two times. So these two are congruent, and these two are also congruent. Now, a kite is not a rhombus. That's another member of this quadrilateral family. But it's not one that we're covering in this video, and kites don't get to be a rhombus. A rhombus has all the sides the same. We want two different pairs of congruent angles in order to be a kite. Now, kites have a cool property on top of their definition that whenever you draw a diagonal through that kite, you end up with a right angle from those two diagonals. So if I'm looking at this shape in here, I know that these two things are going to be perpendicular. So we know that the measure of angle 2 has got to be 90 degrees because of this property up here. So we know that 2 has got to be a 90-degree angle. Now there was a little typo in my diagram, so I moved the 1 and 3 that was over there over to here. So if I wanted to figure out what the measure of this angle is, I can see that inside of here, I've got like a little right triangle. And I know that a triangle has 180 degrees. So I know that 180 degrees has got to equal the measure of angle 3 plus the 90 degrees that I just got plus this 39 degrees down here. So that means that after I do a little solve, subtracting the 90, subtracting the 39, that the measure of angle 3 has got to equal 51 degrees. To get this angle up top, remember, if this is 90 degrees and all of this is perpendicular, that means that's also got to be 90 degrees in that top little triangle. So once again, we can say that 180 degrees equals the measure of angle 1 plus 63 degrees plus that 90 degrees. I'm just grabbing the three angles that are inside of there. So subtract 90, so that is going to be, here, I'll write it out this time. 90 equals the measure of angle 1 plus 63. Subtract 63 from both sides, and I get 27 degrees equals the measure of angle 1. All right, now these last two are a little weird. The idea that I want you to think about for these last two, it's not super important for this kite stuff, but the idea of these other two is if we think about this triangle over here, there's only one way to make this triangle with this length, and this length. I can't like wiggle these sides around very much if I keep these lengths here fixed. If these lengths are fixed, then it's got to be the same sort of shape over here. Imagine taking everything here and flipping it to the other side. So that means that these two have got to be the same. So 39 and 4, they've got to be the same. The measure of angle 4 has got to be 39 degrees. Same thing up here. These two have got to be the same. The measure of angle 5 has got to be 63 degrees. This is just kind of like bonus idea. I don't think it's as important to what we're learning about with kites, but I think it is cool to check out. That is it for this video about quadrilaterals, particularly about trapezoids and kites. Keep in mind that trapezoids have one pair of parallel sides. Kites have no parallel sides, but they do have this cool pair of congruent sides and congruent sides. Thanks for watching. Bye-bye.